Hey guys, welcome back to Paraclete TV. Today we'll be continuing our conversation about constant rate of proportionality, and we'll be applying that to a graph, and we will be learning how to take a linear equation from the constant rate and be able to apply it to real-world situations. Alright, let's get into it. Okay, so here's where we left off last time. Let's remind ourselves what a proportional relationship is. A proportional relationship is one variable is always a constant value times the other. So what we did last time is we had the equation x equals 3y, or y equals x over 3. And we had set values of x equals 3, 6, 9, and we solved for y. So we found y equals 1, 2, 3. We turn these into coordinates and graph them on the coordinate plane here. And we had our equation x equals c, y. Now today we'll be changing that equation a little bit to more generalized use. Okay, so we're gonna introduce the topic of independent and dependent variables. So when I say an independent variable, that is something that doesn't change because of something else. So for an example, a really common example is time. So time goes on regardless of what we're doing, where we're running, what we're buying, this type of thing, right? Time just continues. But a dependent variable depends on the independent variable. So for example, if we are running 6 miles an hour and we're running for 2 hours. That's a crazy example, but anyway, time is going to go on forever and ever and ever, right? But the distance we run depends on how long we run for, right? If we're running 2 miles an hour for 30 minutes or half an hour, then we're only running 1 mile, right? The distance depends on how long we run. So, in all cases of linear relationships, which we're trying to find here through the constant rate of proportionality, x will be your independent variable. That is the variable that will not change, regardless of anything. Y is the variable that does change. So, if you have 6 cans that cost 25 cents each, the price, total price, will depend on how many cans we buy, right? So we can transform our equation from before, that x equals cy, where this is the constant of proportionality, into y equals mx. And this is a really common way of writing a linear equation where y is the dependent variable, m is the slope of the line, which we'll get into, and x is the independent variable. All right, so let's take an example. Let's do the cans again. Okay, so I have an example here. We're at the grocery store, and each can costs 35 cents, or $0.35. The total cost depends on how many cans we buy. So when we're at the checkout and we have a certain amount of cans, the total cost depends on how many cans we buy. So what is x, what is y, and what is m? And then can we draw the line on this coordinate plane? Okay, so we have a chart here that's talking about cans and our total price, right? So we go to the store, and the first thing we buy is pineapple. We have 1 can, and it doesn't matter what kind of food we're buying, because at this grocery store, all cans are 35 cents. So we have 1 can. If that's all we're buying, our checkout price will be 35 cents. But that's not reasonable because we buy more than just 1 can. So we also pick up some tomato paste. Yum. All right, so now we have pineapple and tomato paste in our cart. We have 2 cans, and so our price will be 35 cents each can, or 2 times 0.35, which will be 70 cents. Right? All right, we also pick up some tuna fish. That's 3 cans. And that's a price of $1.05. All right, and one more can, we get some soup. That's 4 cans in our cart now, and that is $1.40. So, as our number of cans increases, our price increases. So, but number of cans will always increase independently from the total cost. And a hint in the wording, the total cost depends on how many cans we buy. So, our independent variable will be number of cans. Our dependent variable will be cost. And what is our M? Well, what was the rate or the constant value that we multiplied cans by to get total cost? 0.35, right? 35 cents a can. So now, using what we have here in this chart and the cans in our cart, we know that X is the independent variable, number of items, so X in terms of cans, we'll have 1, 2, 3, 4. Our dependent variable is the total price, right? So we'll have 0.35, 0.7, $1.05, $1.40, and I'm gonna label them over here. That's not usually how you label, but all right. So for our first can, our price is $1.35. For our second can, our price is 70 cents. All right. For our third can, our price is $1.05. For our fourth can, our price is $1.40. So we have this line that can be written y equals mx plus b, or y equals mx, or y equals 0.35x, where 0.35 is our slope. By having this equation, y equals 0.35x, we can solve for any amount of cans we want to buy. We can find the total price, right? Because y equals price and x equals number of cans. So, by setting up an equation, you can see how useful it'll be to be able to solve for any variable, for any number of cans we want to buy. If we want to buy 70 cans, we can solve for price. Y equals 0.35 times 70. Or how about 1,000,000 cans? Y equals 0.35 times 1,000,000. So in math, you'll be able to set up equations like this and solve for any variable. And that is extremely helpful, especially when you're working with large numbers and you can't count out 1 can, 2 can, 3 can, 4 can, because that's not reasonable when you have to work up to 1,000,000. Hope you guys find this video helpful on proportional relationships and how to write lines and use equations and slopes. All right, I'll see you next time. Bye!